Good afternoon, and thank you all for coming to this webinar on artificial intelligence and energy management. Before we start, I'd like to recognize our land acknowledgement for Indigenous communities. And we acknowledge that we are on traditional territory of the Anishinaabe peoples. I wish to recognize the long history of First Nations and Métis people in Ontario and show respect to them today. I would also like to specifically acknowledge the neighboring communities of Chippewas of Georgina Island, Chippewas of Rama First Nation, and Beausoleil First Nations. My name is Tim Adamson, and I'm with Sustainable Aurelia on the infrastructure and energy sector. This webinar is part of Sustainable Aurelia months-long celebrations, and so we are very lucky to have Bryce and his team join us today. They will explain what artificial intelligence is all about and how this can manage your energy costs and how this technology can fit in with a sustainable energy future for Aurelia. I've known Bryce for about 15 years, I think, when I worked at Enbridge, and Bryce was involved, if I remember correctly, in preliminary issues around carbon trading and developing offsets in the burgeoning carbon market. I know he brings a wealth of experience today. If Aurelia is to survive economically as well as socially, we all need to start thinking about what our energy future is going to look like, not just for residences, but for our commercial and industrial businesses as well. There is no magic one bullet for us all here in Aurelia, but it will be a mix of solutions. The question is, what should that mix look like? Effectively managing HVAC costs is just one of those options. I will let Bryce, Kerry, and Kathleen explain what this is all about. So on behalf of all of us here at Sustainable Aurelia, thank you all for being here, and over to you, Brainbox team.
And thanks to the City of Aurelia for hosting us today. We're going to give people a view into Brainbox AI, and maybe to set the stage, I'll be introducing Kathleen Reeves and Carrie Wilson as well as part of our presentation team. But just to set the stage, if you think about the cars that we drive today, a car that is
You're on mute.
Hang on. Can you hear me now?
Yeah, I gotcha.
I'll start again. Thanks to the City of Aurelia for hosting us today, and I'll be introducing Carrie Wilson and Kathleen Reeves as part of the Brainbox team today. But I first wanted to sort of set the stage about how Brainbox AI affects the performance optimization of existing buildings. And perhaps the participants can think about the cars that we drive today. Our cars today are using AI in many different ways. You might have parking assist, where you're backing into a parking spot and your car's beeping at you or giving you a view on a screen how to align that car perfectly. Some cars actually will park themselves today. And there's other features like lane assist, where your car will bring itself back into a lane if you cross a line on a highway. And if you've ever had the opportunity of being behind the wheel of a Tesla, it has a autopilot feature where you can actually let go of the steering at highway speeds. And so the catalyst for Brainbox was really that thought of thinking about, well, if we're using AI to help in these dynamic environments of a moving car at highway speeds, why can't we apply those same types of applications to the biggest energy burn in a commercial building, which is HVAC. Before I get started, we're going to introduce Carrie Wilson, who's the founder of our parent company, Real Term Energy. And he actually has already a relationship with your municipality in what Real-Term Energy is doing. And then after that, we'll move over to a presentation by Kathleen, more focused on Brainbox AI. So perhaps, Kathleen, if you can maybe share your screen, and then Carrie, I'll let you take it from there.
Great, thank you, Bryce. Screen coming up. So good afternoon. Thank you very much, the City of Orillia, for allowing us to have a presentation here on our sustainability activities with the City of Orillia. Real-Term Energy has been around since 2013. We do smart LED upgrades for streetlights. Have done throughout Ontario, as I say, since 2013. Can I have the next slide, please? We first became involved with the City of Orillia back in, I think, July or August of 2019, where they were interested in upgrading their existing streetlights from the old HID, high pressure sodium, to LED lights. And at that time, they actually opted to take advantage of smart controls, which instead of a photocell that controls the lights on and off just depending on the time of day, actually can be used for dimming and for communications backhaul. So they elected to do that. Our company does all of the things that you see on the screen here, including Brainbox AI, which is what everybody is here to see today. We incubated that company going back about 3.5, 4 years, launched it in May of last year. And it's become something we're very, very happy with, very proud of. So Kathleen is going to talk to you all about that. If I could just have the next slide, I'll just give you the results of what those first activities were with the city. So we are currently just finishing off, we'll be finished in a couple of weeks, about 4,300 energy efficient LED streetlights. They're going to save about 72% of the energy that they were currently spending in the City of Orillia. And as I said before, they're adding 4,300 smart lighting controls. This is the foundation of a smart city infrastructure. So those little light communication lines there are, when Bryce was talking about autonomous vehicles, et cetera, that communication network can be shared with other types of smart city devices that will use that communication network to go back to a central server to actually give the City of Orillia the ability to begin laying its smart city infrastructure. So aside from the energy savings, there are some very significant maintenance savings because these LED lights don't require very much maintenance. And in terms of just the annual GHG greenhouse gas reductions, they're saving about 70 metric tons a year. And over the life of those luminaires, we anticipate saving about 1,600 metric tons. So the City of Orillia is actually one of the last to do an LED upgrade in the province of Ontario, but they're one of the few that have actually decided to put in the smart controls. So in many ways, they're coming from the rear, but they're very much ahead of many of their other counterparts. So we're very pleased to be working with the City of Orillia and to be. Let me turn it over to Kathleen Reeves, and she'll tell you all about that part of the presentation. Thank you.
Same time. Thank you, Carrie. So just as a quick agenda today, what I'm going to do is I'm going to run through basically the challenges that we see in commercial buildings, how artificial intelligence can help, and basically how Brainbox is using artificial intelligence in buildings, and what an example of some economics could look like for a medium to large size building. So when I started at Brainbox, I actually did not know that HVAC systems are responsible for 40 to 60% of your utility bills. In addition to that, depending on your building, of course, but up to 30% of those energy saving or the energy consumption is wasted. From my previous companies I've seen and worked with, I know that current energy efficiency methods are very time-consuming and costly, and poor HVAC operations can really lead to high levels of occupant complaints. People are always too warm or too cold. So this is what Brainbox is addressing. So today with HVAC systems, they are reactive, they're schedule-based, and they're rule-based. So if you have two set points and you say, okay, once it hits 22, turn on the AC, it's all very reactive to what the temperature is and how that's working. However, if you take a look at a building, Things like weather are always changing, occupancy is changing, the utilities might change tariff rates, etc. So what we need is a dynamic solution. So what Brainbox does is they take your current building management system and we enhance it by adding a layer of artificial intelligence on it. We take it from being a reactive solution to a proactive or preemptive solution using artificial intelligence, deep learning, and cloud computing. Now, why is this important? One, you'll be able to save up to 25% on your total energy costs. And I have never seen any one project be able to save this much energy. I mean, really, other than LED lighting, it's pretty incredible. Two, it'll help decrease your carbon footprint by 20 to 40%. We'll have 60% improvement in occupant comfort, and I'll talk about how we measure that in a moment. And then what I find most important is a lot of our, municipalities, our school boards, our public sector, and even our private sector, they just don't simply have time because they'll often have a lot of buildings and they won't have true building operators at each one of their buildings. So it's important that when we came to the table, we were able to come to the table with a solution that was really easy to install and didn't require a whole lot of human interaction. So how does AI work? If you take a look at this black curve, this is a reactive HVAC system. So as you can see here, the temperature might start to rise and you'll have my goodness, I'm having a mind blank. Thermal momentum. Once it hits that set point of when to turn the cooling back on, it doesn't just go right back down. It'll continue with that momentum to heat up before it'll come back down, and it'll often go outside your set point. So when we say that we are going to improve occupant comfort by 60%, we do that by flattening this curve. Brainbox will foresee the underlying event, the undesired event that's going to happen. So it'll know, in 2 hours from now, the sun's going to be hitting this side of the building. So we should start to cool down slowly before it gets to that point where it gets too hot and it becomes reactive. So as you can see, we're flattening the curve. So how Brainbox works is the first thing we'll do is we will install an edge gateway box. And this is about a 12-inch by 12-inch box to your building management system. The second step that happens is data extraction and mapping. As we said earlier, we will take the data from your building automation system and then we will enrich it with other data sets like weather, occupancy, utility tariffs, and the AI will all go through this 6 to 8 week learning period. And it'll create a unique building energy profile just by observing, learning, and making correlations. Once we get to the point where we are making predictions to 99.6% accuracy, that is when we will say, okay, it's now time for us to drive the building or switch to autonomous mode. Once we switch it over to autonomous mode, then what will happen is we'll start writing back to your BAS to say, okay, let's open the damper. It'll make different decisions with your HVAC system to make sure that we're never going outside those set points. And then finally, it'll always be continuous learning. So one of the questions that we get is, what if you have your learning period during the pandemic when my building's not occupied? Or what if it's during a shoulder season? How will it accurately know what happens in the winter? The learning never stops. It always is continuing, and it'll actually update the information every 5 minutes. Some other advantages is that because we know there's limited maintenance and building operators, we provide a monitoring service 24/7, and this is at no additional cost. Our building engineers will be watching your building for alarms, for example, if your damper's stuck open or if a sensor's out of range. And this will allow us to notify you of any potential issues that we are seeing. We want to make sure you don't have any failures because we want to make sure that we are able to deliver our results to you. Secondly, we are control system agnostic. So you must have a building management system that supports BACnet protocol or Lawn Works or Modbus or Niagara Fox, but we just need to be able to have the ability to talk the same language as your BAS system. The next one is that there's no sensors required. So we have a dashboard providing insights, energy savings in kilowatt hours, in dollar savings. We show you the comfort metrics, and we'll also show you what types of algorithms that we are deploying in real time. The other question is well, what happens if we need to disengage it? On the dashboard, you have the ability to manually disengage the Brainbox if you need to. Examples of algorithms that we use, and we have now over 40 algorithms at this point. One of them would be like the optimum system start and stop times, economy cycle, so when to use outdoor for free cooling instead of using the HVAC system, again with night purge or preemptive cooling and heating. There's quite a few, and if you're interested in learning more about the algorithms, we can do a follow-up afterwards. Now, depending on what your goals are, we can help. In the midst of the pandemic, a lot of people have really thrown the energy measures out the window to increase the number of air changes per hour to try and mitigate the airborne transmission of the virus. This does use more energy versus saving energy, but Brainbox will help you make the best decisions so you can make sure that you keep your increased costs down while maximizing your fresh air. So this is an example of what the economics look like. So this is a school example. In this example, this building is 150,000 square feet. The annual energy spend is approximately $3 a square foot. That's including your gas and your electricity. We project an annual savings at about 20% at this specific building. So this was a $90,000 saving. And the fee, what we would charge is a portion of that. So we generally charge 25%. And then in your first year, we do have an onboarding fee that will amortize over the first year. But the net savings on this project was $66,000, so it's very significant. The other thing is there's not a lot of risk. So what we do is we will come in after we do an initial assessment to determine if your building is a good fit. We'll come in and we will look at, we'll come in and install the unit. When we're installing and onboarding the building and building your unique building profile and the AI is learning, we don't charge you for this period. And in month 3, when we get to that 99% accuracy of predictions, then we'll turn it over and we'll start to slowly introduce algorithms. In month 3, we might have half of our algorithms up and running. And then by month 4, you should be fully operational. So you'll actually be able to see the savings in your building live. At the end of month 4, this is the cool part, and this is probably not going to last much longer, but you would then have the option to discontinue. So before you spend anything, we're going to come to you and we're going to say, here is the proof. Here's what we said we're going to do. And here's what we've done. At that point, if you don't see the cost to savings ratio great enough, at that point, you can just opt to stop and we will disconnect and walk away. However, nobody does this because the savings are always greater than the costs. So what we'll do at that point is start the 12-month agreement. And it is a SaaS. So it's a service as a subscription type model. And then what else am I missing here? So I think that's about it for this slide. How do we determine if your building is good? So here's a list of questions that we will go through with you to determine if your building is the right type of building for our technology. We'll look at the building type, the amount of electricity cost and gas cost. We'll look at the square footage of the building and how much of that square footage is under management of the BAS system. We'll look at the protocol, communication protocol, whether it's BACnet or not. And then if you have drawings, that's always very helpful too. After we get that information and the utility bills, we will come and make a proposal to you. You'll sign an order form to get started with the form of trial, and then we'll get you onboarded. A little bit more about our company is we were founded in 2017 and we launched in May of 2019. We are headquartered in Montreal, Canada, except our global impact, we are growing like crazy all over the world. Just last week, we announced new partnerships in Ireland, Italy, Australia, the UK. We are growing massively and very quickly, and we've got lots of properties that this technology is being proved out on today. So, Bryce, I will hand this back over to you if you want to do question Q&A.
Sure. We can answer those questions together if you like.
Am I still sharing?
Yeah.
Stop.
And can you guys hear me okay?
Oh, we do have some questions already. This is great.
Yeah. So I'll address the first question from Stan. What's the smallest building for which installing Brainbox is still cost effective? Theoretically, there isn't too small a building. From a business perspective, we're targeting buildings that are 70,000 square feet and up. We're looking for a building that has a centrally controlled BMS, as Kathleen pointed out, and that system is controlling 80% or more of that building. So that's kind of the sweet spot for us. Now, that being said, we have done a retail chain of stores where the average store size was somewhere between 10,000 and 15,000 square feet. So it really depends on the portfolio of buildings that we're talking to and other things. But from a rule of thumb, we are looking for buildings of bigger scale, 70,000 square feet and up. There's another question here. How does the system manage electricity outages? And I don't have an answer for that question, actually, off the top of my head. I'm not sure, Carrie or Kathleen, if you've addressed that question yourself. I haven't come across that one. But we will get you an answer and send that out to the group after I check with our technical team on that one. Anything to add there, Kathleen or Carrie? No, I haven't seen that one.
I would imagine that it's the same as the BAS because we're simply just layering on top of the building automation system. So we would probably manage it the same way as your building automation system does.
Yeah, that's probably right. Now, how long do we need to develop the algorithms? Well, we actually already have the algorithms developed. As Kathleen pointed out, we've got a library of about 40 algorithms. Now, we don't apply all the algorithms to a particular asset. Instead, after we go through a building survey and get the answers to some of those questions we just saw in the last few slides, then our team of engineers then basically handpick somewhere between 5 and 6 algorithms that are going to be bespoke to that particular asset. Any other questions?
Like the handout, if you look on the right-hand side of where the chat is, there's a black plus sign button. If you click on that button, you will see your resources, and there's the handout right there that you're able to download if you wish.
Yeah, it's Tim here. Actually, I've got one other question. It's about the, you said it's agnostic for controls, but have you installed your systems with all controls, or has there been a preference by one manufacturer over another?
No. Yeah.
No.
Go ahead.
Go. Well, I'm probably going to be the same answer. We're pretty much agnostic to all control systems. We've worked with most of them at this juncture, and it really, as long as there's connectivity to the BAS, which we've been able to do with most control systems out there, there isn't an issue.
Okay, that's great.
I do see there's a question here that perhaps Carrie can address. during the LED installation discussions with the City of Aurelia, did you look at your solution would work with any of their buildings?
I'm just trying to see the question here. Hang on. During the LED installation discussion, did you look at your solution while working? Yes. So yeah, in terms of the actual city of Aurelia, we did take a quick pass at the City Hall building, which is a fairly old renovated building. I don't think we put any formal proposal or actually investigation of it, but we certainly plan on following up with our Brainbox colleagues to look at that building more carefully. It's as most of you would know, I don't know what vintage it is. It's certainly 1800s or early 1900s, and has been substantially renovated. So we'll find out if it's a good candidate or not.
And there's another question about government funds. So, given it seems to me such a great technology and everything, are there any funds that you know of that could help support deploying this, even though you're saving lots of money for that?
Go ahead.
So currently, we do not apply for utility incentives through the IESO. And the major reason of why we don't is because a lot of those utility incentives are for capital projects. Because there's no upfront cost to install and it's more of a cost recovery play, we are not currently getting government funds to do so.
Okay, so have you met with Enbridge or Hydro One to try and promote this? And I was just interested in what their reaction would be.
To be honest, I only joined the company 8 weeks ago, so I personally have not.
Okay.
But it is in the works. Like, I know that we are looking at working with IESO for potential funding in the future. We just haven't got there yet. We haven't needed it, to be honest. The Brainbox has really sold itself as far as the cost and the cost recovery goes.
Yeah, given that it's so low risk for the building owner with no upfront capex, and as Kathleen pointed out, we've got that learning period and an opportunity at any time for the building owner to back out away from the project if they don't like the savings that they're seeing. So it's very low risk to adopt the system.
Yes, I see all the companies who've got it. Those are all in Ontario, are they, or right across the country?
Yeah, we're right across the country. We're all over the world at this juncture with various building types.
Oh, okay. And then, well, I don't mean to dominate. Are there any other before I carry on? Are there any other questions out there that any of the attendees would like to ask?
I do see one in the chat here that says, what kind of data analysis can be done from the data? Trends due to changes in temp? Do we study for the improvements for the AI? So it's the AI that's doing the data analysis on our behalf, frankly. We're taking not only a sweep from the data availability from the BAS system itself. And in that case, for instance, you could take a 1 million square foot building. It could have upwards of 170,000 sensor points in that building that represent various equipment and temperature and other things. The AI is able to monitor all of those data points simultaneous and make subtle tweaks and adjustments to the system to deliver the comfort settings with the best performance. It would take an army of humans to do what the AI can do in that instance, as well as Kathleen pointed out earlier. While the AI is monitoring the data points that are available from the BAS, it also is monitoring the local weather station closest to that address. It's monitoring cloud cover in that area. It can also monitor occupancy data if that's available. And then In terms of analysis from a customer perspective, we do present the customer with a dashboard that shows real-time energy savings, real-time dollar savings, and also the equivalent greenhouse gas savings for that asset. And there are other views that are being developed for the dashboard, but right now, those are sort of the main areas that you can use.
Oh, that's great. So any other questions from the attendees? I'm just looking at the time here, we're almost bang on. I'm not hearing anything. Well, with that, I think I'll bring this webinar to a close, and I just wanted to thank all three of you very much for your time this afternoon, and I'm sure we'll be following up with you with some more questions, and because Aurelia, through Sustainable Aurelia, we're trying to do some sustainable energy projects, and to me, this should be embedded in our thinking. So I'm sure we'll be talking more. So with that,
well, thank you, Tim. Thank you, Tim, and thank you to others on the call for attending this webinar. We look forward to opportunity with working with anybody, and feel free to reach out if you have more questions for us.
Okay, thank you, Sophie. We'll close it off now.
Thanks, everybody.